Hello, so today we are going to do this problem, which is problem number 3 from Leetcode Weekly Contest 379. So basically what this problem says is we have two arrays. We have nums1 and nums2, and each of them is of even length of value n. And what we want to do is remove n divided by 2 elements from each array, such that after this removal we want to insert the remaining elements into a set. Okay, and then the goal is to get the maximum possible size of the set that we can get. Okay, so for example, if we take a look at the first example here, the only way to maximize our set size here is to remove these two duplicates, remove these two, so that way basically we remove n divided by 2 from each, and then we have 1 2 and 1 1, which means we have final set of the just two values, 1 and 2, so we return 2. For this example, again, we want to remove half from each, so it's wiser to remove duplicates because the set will already, when we put them in a set, the duplicates will already be removed. So if you remove something not a duplicate, like for example here you remove, let's say 4 5 and 6, that's really sort of not useful here because you got rid of unique element that you could have gotten as an additional thing to increase the size, right? So that's something to keep in mind here. But in this case, we can maybe decide to remove these. And for this case here, we would have to remove n divided by 2. So let's just maybe say, for optimizing, we should remove something that is not in this one, right? So we remove these two. We have to remove a third one, so we just choose any one at random. You could remove 1, 4, or 5 or 6. So if we do this, then we have 3 uniques here, 2 uniques here, so we have 5. So that's the idea here. The constraint are 10 to the power of 4, so that tells you can't do really an event. So here, what you notice here is that we are asked to remove elements, right? But you should always, when you have a problem and the way it's stated is tricky, think about stating it differently, maybe in the opposite way, and see if you can solve it that way. So here, removing basically n divided by 2 elements, what is this equivalent to? This is basically equivalent to keeping the other half, right? So keeping n divided by 2, and then we're discarding the rest. So now we need to think about our goal is to maximize the set size. Okay, so we need to think about how do we keep, which element to keep such that set size is maximized, right? First, let's say we have nums1 is maybe 1 2 3 4 5, and then let's say nums2 is 1 2 3 2 3, something like this, and maybe this is 5, like this. But we need to make them equal and even. So this is even, that's good, but this one is another one, so let's say it's 4, right? Now, one thing to think about, just if we think about just nums2, the elements to keep from nums2, if we keep, let's say for example, all 4, we need to keep only 3, so let's say we keep this. It really doesn't make sense to keep a duplicate here, because if you keep a duplicate, then once you get it in a set, it would be actually equal to only 3 and 4, right? So if you add a duplicate element, an element that you already added, you are not gaining anything in terms of your goal, which is maximizing the set size. Okay? Here we are better off using an element that it's not a duplicate, so we are better off using 2. That way we have a size of 3, right? So that's the key insight here, the key first insight. And same thing applies here. So basically the first insight for us, so was this, and then the second one is that always keep 1 and discard duplicates, okay, within the same array. Okay, so that's the second observation. Now, another observation is that there are some common elements here. We have 2 here, 2 here, okay? So let's say we don't take duplicates, we take unique elements. So we take from this one, 1, 2, and maybe take 3, right? Let's say here we take unique, a portion of the unique, so we take 2, 3, 4. Now, we need to combine these two. That's what the problem says, to keep n divided by 2 from each and then combine them in a set. So once we combine these two in a set, that will give us, this one is these two are duplicates with here. So we have 1, 2, 3, 4 as a set. Okay, so basically, let me actually write it like we have, if we combine them, we would have 1, 2, 3, 4, a set of length 4. But let's think about this here. Can we do better? You can see that a 5 is a unique element that could have been here and could have made this size bigger, right? So what if, for example, in this case, because we already have a 3 here, what if we just take the 5? The 4 is not really useful to take it because it's already here. But if we take the 5, then now we have this, and the size is bigger. Now the size is 5 instead of 4. Okay? And so what did we actually do here when we said we should better choose 5? It's basically for the common elements between this one and this one, right? We shouldn't take duplicates as well from those. Okay? We should take as many unique ones as possible. But how do we do that? Well, that automatically means we need to determine the common values. So let's determine the common values of these. Well, the common values are 1, 2, 3. Well, in this case, it happens to be everything, which is a bummer. So let's change this a little bit. So maybe let's make this in a good way. So let's make this 6. And let's make this, 6. I think that should be good enough. So the common elements are just 4. 5 is not there. So these are the common elements. So what makes sense here actually is to take the common element only from one of them. Okay? But which one? Well, it would be easier for us to just determine the uniques that are not common and then grab as many of those as we can and then take from common, because then we would maximize the maximum number of different elements we can take. So what do I mean by that? So let's adjust a little bit. So we know these are the commons. So let's, for this one, take the uniques that are not part of common. So that would be 5 and 6. Okay? And from this one, let's take the unique ones that are not part of this. Well, it happens that all of them are, and so let's change this maybe a little bit and make this 7. And so if we do that here, then we'll be able, let's take the unique that are not part of common. So that would be just 7. Okay? So now we took 2 out of this and 1 out of this, but we need to take 3 out of each, right? And divided by 2 is equal to 3. So in this case, we are missing 1 here and we are missing 1 here. So in this case, we can take from common. So we take 1 from common for this one, and we take 2 from common for this one. And this way, we get the maximum possible size when we combine, because the size is 6. Okay? So basically, the idea to maximize the size of the set, we know the commons are common between both. So since we are combining the elements from the two lists, if we take the commons from this one and from this one, then we would have duplicates. And by the same reasoning, we didn't want to take duplicates here. It doesn't make sense to take duplicates from the common ones. Okay? And so in order to avoid that, we just get the set of the common values. We take all the unique from this one that are not part of the common, and we do the same thing for this one as well. And then once we are done, we see what we are missing and we take it from the common. But we take it only once, because if we take it twice, that doesn't add anything to our goal of maximizing the set size, because the set will eliminate duplicate anyway. And so the third observation that we need to make is basically for our solution, we need to take unique from nums1 without the common element. Plus, we need to, then we add up the unique from nums2 without the common elements. And then we add up common elements that can fit, right, in a allowed portion, which is basically n divided by 2 for each array, which is basically 2 times n divided by 2, okay? Another way to think about this is in terms of like a Venn diagram. So let's say this is nums1, let's call it n1, and this would be nums2. So what we are doing is we are taking the uniques of this one, so this section here, and then we take the uniques of this one, and then we take the uniques from common, but we can only take n divided by 2 for each, and so we only take what we can. And so that's basically, if this one was, so basically n divided by 2 here, we see how many uniques did we get. If that's not n divided by 2, we take what's left from the common ones, and we do the same thing for this one. Okay, so I hope that was clear. Now let's code it up and make sure it passes. So to code this up, we just need to do exactly what we said here. So we need the unique of, so we need, of course, first the sets of both elements, so the uniques of both, before removing commons. So let's call them S1 and S2, so they would be the set of nums1 and then the set of nums2. Okay, and so we'll say unique 1 from S1 without common, but we also need to get the common element. What are the common elements? Well, the common elements are just the intersection of the two set S1 and S2, common between both. And so to get the uniques from S1 without common, well, we can just get S1 and then remove the common elements, right? And we want to get just how many elements we have there, so we can just get the length. And the same thing, similar thing for S2, except we are subtracting from S2. Okay, so now we know that our solution would need to have a sum of these two, plus what we can take from common. But first, let's just add up these two. Okay, but what can we take from common now? Now we said that for common, we want to take the remaining. So first there was, this one had just 2, this one has 1. So this told us that we have 1 remaining we can take from this one, and 2 remaining we can take from this one. So overall we had 3 remaining that we could take from common. And so we are just looking for the remaining overall that we can take. And so let's just call them remaining, remaining needed to keep, right? And so that would be basically this one, but we want to see how many remaining, so basically it's n divided by 2 minus this. Be careful of actually here, because here if this was bigger then this would be negative, so we need to make sure we don't take for the ones without common, if that value by chance maybe was, let's say we had something where nums1 was like this and nums2 was like 5, 6, 7, 8. Okay, so without common it's actually 4, so it's more than we are allowed to take, which is just n divided by 2. So we need to make sure we don't go beyond that. So how do we do that? We just take the min of this and n divided by 2, and the same thing here, the min of this and n divided by 2. Okay, since it's even, we could actually also do that, but it doesn't really matter, so let's just do this. Okay, so we take the min of n divided by 2. Now we are guaranteed that this is bigger or equal to 0. Okay, but it's not just this one, it's this one for the first one. So let's call this remaining needed for S1, and then we have remaining needed for S2, which is just this one, okay? And so what we need to take from common is these two. And so, but we don't know, maybe common is either, the number of elements in common is either bigger than these two, what we need. So in that case, we can only give what's in common. Or maybe it's smaller, where basically we need 4 and 5, but this one has only 2. And then in that case, this can happen if you have a lot of duplicates element. In that case, we can add up only the number of common elements we have, right? So basically, it's going to be the min of common and the sum of what we need, right? Because we only have the common elements that are unique, that are available, right? And so here, basically, let's call remaining. Let's call it remaining, and then that's what we add here. Okay. I think that should be it. So let's run it. Yeah, we need n, which is basically just the length of the array. Okay. And then looks like this is a set, so we need to get of course, the length. And that should be it. Yep, and let's submit. There is one wrong answer. Let's see what's the issue. This is a division as well, so we need to just fix it like this. Okay, looks good. Let's submit. Okay, cool. So that passes. Now, in terms of time complexity, all of these set operations are at most both intersection, length, creating a set. All of these are O of n operations, and these other ones calculations are just O of 1. So the overall time complexity is O of n. In terms of space, we are creating 2 sets here, another set here, and so we are creating sets of length n, so at most, and so O of n space as well. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you in the next